Hi, for the sixth grade, this is your video for Tuesday, October 20th. Already getting toward the end of October, it's hard to believe. We only have through next week for this quarter, and so any work that you need to have done needs to be done by that time. As far as for your work text today for science, this is your science video, in case you didn't know that. I never gave you the word for history, did I, for the other day? Okay, that's right. All right, so page 52 to 54, so if you look at 52, it's the backside of the one you did yesterday, and basically what you're going to do is you're going to explain in detail, all right? It's not hard to do if you pay attention to what it says. The first one is talking about Jack puts ice in a glass and then pours his favorite soft drink into the glass. You may have done this yourself at certain times. He drinks about half the drink and then goes outside to play. He comes back inside, he drinks more of it, but the drink doesn't taste the same. Is the drink in the glass more concentrated or more diluted than before the ice melted? What happened to cause the drink to change? You need to answer both of those questions in 2 or 3 sentences. You got all these three situations, and you're trying to figure out why did these things happen. All right, the first one you probably already know. Now, as far as page 53 and 54, this is a study guide, and a good study guide to be able to use for your quiz that is coming up on. Let's see, we have a quiz. Well, you had a quiz today, and then you'll have a quiz again coming up toward the, let's see, on Thursday. And so that will be thing, and then let's see. Oh, then on Friday we have another experiment to do, a boat floating experiment. You get to create a boat and try to figure out which one floats the best. All right, so let's go to your reading now, page 76. And starting there, it's talking about solutions today. Yesterday we talked about mixtures. Today we're talking about solutions. Salt and sand do not mix evenly, but water added to the mixture does mix evenly with the salt. Salt and water form a solution. Okay, now pay attention to this definition. A solution is a mixture in which all the substances are spread evenly throughout. Okay, so the salt dissolves in the water and it seems to disappear. Dissolving is the process in which the particles of one substance separate and spread evenly throughout another substance. Other substances can dissolve and form solutions as well. Suppose you mix sugar and iced tea. You cannot observe the grains of sugar in the tea because some physical properties of the sugar have changed. However, if you taste the tea, you know that the sugar is there. The sugar has undergone a physical change to form a solution, but it has not become another substance. Scientists have special terms they use to describe the parts of a solution. All right, so these are important to know because these are going to be on the test, on the quizzes. You need to know these two things in particular right here, right now, what they are. All right, and they sound close to each other, so you really want to make sure you memorize these terms. Scientists have special terms they use to describe the parts of a solution. A solute is the substance that is dissolved. So in the case of the sugar in the tea, the solute would be the sugar. That's the thing that's going to be dissolved in the tea. The solvent is the substance that dissolves the other substance. All right. So in that case of the tea and the sugar, so the tea would be the solvent. That's the thing that breaks down the other thing, causes the physical change. In salt water, the salt is the solute and the water is the solvent. So it's not hard to remember, okay? But for some reason, because those words are about the same size and they both start with S-O-L, that seems to cause people problems. So don't get confused between them, all right? Water is the most common solvent on the earth. It is often called the universal solvent because so many things dissolve in it. Water's ability to dissolve many substances is very important to life on the earth. You might think that all solutions are formed from a solid being dissolved in a liquid. From a solid being dissolved in a liquid. That's not the case, however. The solute and the solvent of a solution can actually be a solid, liquid, or gas. So you can have anything. It's not just a liquid. This means that there are different types of solutions. Air is a solution of gases. The oxygen you breathe and the carbon dioxide plants need are two of the most common gases in the air solution. A soft drink is a solution of a gas and other substances in a liquid. The bubbles you see are from the carbon dioxide gas that has dissolved in the liquid. The carbon dioxide in the soft drink is the solute, and liquid is the solvent. You use many metal products that are formed from a mixture of two solids. These mixtures of two or more metals, and this is another important term. Mixture of two or more metals are called alloys. You probably have heard of that before, but they're alloys. Sometimes they're used for strength. Sometimes they're used to save money because it costs less because of the alloy is you can mix it with the metal that's cheaper, and so on and so forth. That's the case for coins, actually. The reason they put those different types of metals in nickels and pennies is so that they could save money, because otherwise it costs more to create a penny than the penny is worth itself. A nickel coin is actually an alloy of the solid metals nickel and copper. Even 14-karat gold jewelry is gold that has other metals added to it. So pretty interesting to think about. All right, so concentration and saturation. All right, now here are two more terms that are often difficult for people to understand or to get. So here we go. Concentration and saturation. The concentration of a solution is the amount of solute that is dissolved in the solvent. Think about it like this. The solute, the sugar. The more sugar you put in, the stronger the sweetness is, okay? And so that might help you to remember the concentration. It is much more concentrated with the sugar. Now, you think about a cleaner like bleach. That's one of those things that can cause you some problems. But as far as a cleaner and its abilities for bleach, when it's stronger, you smell bleach longer. If your parents use bleach in the laundry for the whites, after you may walk by the washer and dryer or be around it, and even after the clothes are done, you can still smell the bleach because it's more concentrated. The stronger the solution, or the stronger the solution is going to be. So it says, suppose you mix a powdered fruit drink mix with water. The powder contains flavoring and sweetener. When you mix the powder with water, the powder is the solute, and the water is the solvent. By altering the amount of solute, the concentration of the fruit drink can be changed to suit your taste. If you put a lot of the powdered mix into the water, the solution will taste strong. It will be concentrated. Concentrated means that the solvent is holding more than a normal amount of solute. If you just put a little of the powdered fruit mix into the water, the solution will taste weak. And you see there the picture of the diluted pitcher of fruit drink or powdered mix, whatever you want to call it. It says it will be diluted. A solution is diluted when there is less than a normal amount of solute in the solvent. Sometimes the concentration of a solution can be adjusted to make the solution more useful. Often, a cleaner is mixed with water to form a cleaning solution. To wipe counters and sinks, you might use a diluted solution with only a weak concentration of cleaner. To clean a very dirty floor, though, you would use a more concentrated solution so that the detergent can do that. Okay, and so if you continue to add more and more solute into a solvent, the solution will become saturated. Right? This means that the solvent is holding all the solute that it can dissolve. So if you keep adding a powder a mix like a Kool-Aid or some other kind of mix, or if you make lemonade from the powder thing, you keep putting it in there, it's going to get to the point where you put so much in that it can't be dissolved anymore, because you have to have a certain amount of water to be able to dissolve it, and it won't just you put a drop of water in. Well, think about it like this. Let's say you fill the pitcher with the powder, and you just put a small cup of water, and all it's going to do is make a little bit of a paste, but the rest of it's still going to be dry. So that's called it's being saturated, or its saturation level. All right, the saturation level. Rate of dissolving. Sometimes a solute can take a long time to completely dissolve in a solvent. There are ways to speed up the process, however. One way is to increase the surface area of the solute. This can be done by crushing, crumbling, or cutting it into small pieces. The more solute that touches the solvent, the faster the solute dissolves. This is why rock salt dissolves more slowly than a teaspoon of salt does. Another way to speed up the rate of dissolving is to stir the solution. Stirring brings more fresh solvent into contact with the solute. It helps spread the solute faster. Perhaps you've seen someone sweeten coffee with sugar. Usually he does not just put the sugar in the coffee. He also stirs the coffee. This causes the sugar to dissolve more quickly. Temperature also affects how fast a solute can dissolve. This is because heat increases solubility. Solubility, now this is another term you really need to understand. Solubility is the ability of a solvent to dissolve a certain amount of a solute. The particles in a heated solvent move faster than when the solvent is cooler. This increases the rate of contact with the solute and speeds up the dissolving process. So those atoms that are inside a warm liquid, like we'll just say warm water, they're moving faster. And so because they're moving faster, they're hitting the solute more often, causing it to melt more quickly, okay, and dissolve more quickly. This increases the rate of contact with the solute. Oh, I already said that. Faster moving molecules also spread farther apart. That leaves more room for the particles of the added solute to dissolve. Now, suppose you wanted to add sugar to tea. The sugar will dissolve more quickly if the tea is hot. The sugar does not dissolve as easily in cold tea. Instead, the sugar tends to settle to the bottom of the glass. All right, using matter. Often our love is shown by what we do with physical objects. You've learned about matter and much of its properties, but there's much more to learn about matter and just in how it works. Jesus said that the second great commandment is to love your neighbor as yourself in Matthew 22:39. Measuring and mixing matter can help you obey that commandment, even if it is baked by baking brownies for your teacher, Mr. Jones. Okay. Now, I certainly don't need brownies. In fact, the last few times I've had them, kind of makes my heart race. So I'm not sure. I think the sugar is too much sugar in it for me. So, in any case, we're going to go ahead and make brownies our word for science for Tuesday. All right. That's it. Have a good day. See you tomorrow. Bye.